Right, this is Geometry A, Unit 5, Lesson 4. We're dealing with the side angle side congruence theorem. Also want to deal with one theorem that doesn't work, and that's angle side side. So let's take a look at side angle side. For side angle side, I'm going to construct a triangle to start with using my polygon tool in GeoGebra. So there's triangle ABC. And I'm going to start with an angle. Basically what it's saying is if two triangles have the same angle and the corresponding sides on either side of the angle are the same, then the triangles are congruent. We're going to see if we can prove that to be the case. All right. So in order to construct an angle that is the same size as angle A, I'm going to use the angle copying construction. Okay. So first I'm going to draw a ray. All right, let's use ray here. Okay, so angle D is going to correspond to angle A. And you may recall we use our compass tool to measure a circle on, actually I need a point here. Let's put a point on this side and measure a circle, draw a circular arc right here and copy that circular arc to D. Okay, place a couple points on this intersection and on this intersection, and then measure the gap. Not circle with center, but compass. So I'm going to measure FG and measure FG again and copy it to H. Okay, there we go. And you may recall these steps. If you don't, you want to review the steps for constructing a copy of an angle. And now we're going to draw a ray through D and I. Okay, and so this angle, these angles will correspond. So if I grab point B and move it, make this angle bigger or smaller, the other angle, angle D, shrinks and grows correspondingly. Okay, all right, so now I want to make sure that AB is the same length as the side off of D, so let's do that here. So let's grab our compass tool again. Compasses are used for measuring. I'm going to measure AB, and I'm going to copy that to D. And I'm going to place a point at the intersection of that circle here. Okay, here we go. So DJ is the same length as AB. And now I need to measure AC. So grab my compass again and measure AC. And put that on point D. Okay, let me move point E out of the way, because I don't want that to be confusing here. And we're going to put a point on the intersection of the circle and the side, K. Okay, and now I'm going to draw polygon DJK. And the question is, I constructed these to have the same angle D and A, and I constructed them to have the same sides AB and DJ, and the same sides AC and DK. Are the triangles congruent? So let's use our measurement tools to find out. Let's measure the sides and see if all the lengths are the same. AB is 3, DJ is 3, BC is 3.3, JK is 3.3, AC is 4.6, DK is 4.6. Okay, so those side measurements work, and I'm going to measure the angles. Okay, so angle A is 46.9, angle D is 46.9, angle B is 91.6, angle J is 91.6. Angle C is 41.5. Angle K is 41.5. Look at that. And we can verify this works for any triangle by grabbing any of the points and moving them. Okay. As we move things around, let's change things significantly here. 2.8, 2.8, 4.2, 4.2, 3, 3, 42.5, 42.5, 91.7, 91.7, 45.9, 45.9. No matter how I change the original triangle, the other triangle is congruent. All the sides and angles are congruent. All right. That leaves us now to conjecture or think about the angle side-side case. And I'm going to go to my notebook here and get rid of this here. And let's deal with angle side-side. Okay. And I'm going to bring back our grid. I'm just going to look at one particular case to hopefully demonstrate why angle side-side doesn't work. Let's say I've got a triangle here. Okay, and it's A, B, and C. Okay, so here we go. This reaches up to here. This goes down to here. And this goes down to here. Okay, so triangle ABC. And I want to determine, is ABC congruent to DEF if I have a given side and a given angle a congruent angle, and a side congruent and another side congruent. In other words, let me show you what I'm talking about. Let me switch colors here. So we've got AB, which goes over 2, 4, 5, and up 4. So if I go over here and draw DE the same way, over 5, up 4, then AD is going to be the same length, right? And because it has the same rise and run, it's got the same angle as well. So this angle is the same, though I haven't drawn the bottom. Let's go ahead and draw the bottom. Okay, and I'm going to draw it longer than I need to. And I want to draw BC so that it's the same length. Now we might say, well, we can draw BC right about here, right? And draw it the same length, call it DE, right? And the two triangles would be congruent. But actually, let me get my compass out here and show you something. If I set my compass to the same length as BC, try that again. Same length as BC. I actually have two places I could draw a point that crosses the line. It crosses the bottom line here and here. So I could put E here, or I could put E here. If I put E on the right-hand side, it's congruent to the original triangle. They're the same shape. But if I use the other one, like this, they are most obviously not the same shape. So here we've got a triangle with an angle, a pair of congruent angles, a pair of congruent sides, and a pair of congruent sides, angle, side, side, and they are not congruent. So there is no ASS postulate. To review our case from before, there is a side angle side. Notice the angle A and the angle D were given. The sides AB and AC correspond to the sides DJ and DK. So there is a side angle side postulate. Okay, side angle side. But angle side side doesn't work, and the way you can remember that ASS doesn't work is it spells a bad word, right? We don't want to put bad words on our paper.